Okay, so here we are with question 9. Complete the table below. Draw the graph of y equals 2x squared minus 5 for the values of x between minus 2 and 3. Use the graph paper below. Choose a suitable scale for the y-axis. Now, this is 4 marks for this question. So let's start by filling in that gap. So here it's asking us when the x equals minus 1, what is our y value going to be? So what I'm going to do is wherever there's an x, I'm going to substitute in minus 1. So y equals 2. Okay, I'm going to replace that x with minus 1 squared minus 5. Okay. So minus 1 squared. Minus 1 times minus 1 is 1. When we square a negative number, it becomes positive. So it's 1 times 2, which is 2. So we're going to have 2 take away 5, and that gives us minus 3. So that goes in our gap there. Now, our next part of the question is that we have to now draw this graph down there. So when x is minus 2, y is 3. Oh, we've got our y-axis first. We have to draw a suitable scale. So if I look at my scale here, my lowest value is minus 5. My highest value is 13. So to fit that in, 5, 2, 4, 6, 8, that's not going to fit. 5, 10, 15. Yeah, 5s would be a nice scale to use. So I'm going to put a 5, 10, 15, 20, minus 5, minus 10, minus 15. Okay. Which means that every 2 little squares on here will be 1. So let's have a look at this. Minus 2, 3. So across to minus 2, up to 3. Just put a little cross there. Minus 1, minus 3. So minus 1, minus 3. 0, negative 5. So 0 down to negative 5 there. 1 to negative 3. 2 up to 3. And 3 to 13. Okay, so I've got all my crosses there. And now all I need to do is join them up freehand. There we go. And we've got a nice curve there. Okay. And that, actually, sorry, coming back to that one, is worth 4 marks. The first mark is for getting that negative 3. Your second mark is for using an appropriate axis. So they were looking for either going up in 5s or going up in 4s. So we've gone up in 5s there. So our scale was another mark. There's a P mark next for plotting at least 5 correct points. So your plots give you another mark. And then a smooth curve drawn through their points. So we have a nice smooth curve there, which was worth the other mark. Okay. Part B. The sketch of the above can represent only one of the equations given below. Circle this equation. Now, we should know that y equals x squared is a U-shape. So we do have a U-shape here, but x squared would be hitting down at the origin. So it's not that one. X squared minus 3 would be where it cuts negative 3 on our y-axis. So it's still our U-shape, but it would have dropped down to minus 3. So it's not that one. Minus x squared would be an N shape. It would be upside down. X squared plus 3 would be the U shape, but up to 3. And it's therefore that one. So we're saying that that point there is 3. Okay, but you don't need to put that 3 in there. The 1 mark is just for circling the correct value. Okay, question number 10. This is where our tracing paper comes in quite handy, because we are looking to rotate triangle A through 90 degrees anti-clockwise about the point -2, 3. Okay, so 90 degrees means I'm going to do a quarter of a turn. Anti-clockwise, so I'm going to go to my left, about the point -2, 3. So I need to mark that on here first. So -2, 3. So I'm going to mark that. Now a little hint with your tracing paper, try and put it on straight. If you put your tracing paper on straight, doing a quarter of a turn is quite easy. But if you put it on at a bit of a diagonal that way, when you're doing a quarter of a turn, it's quite tricky to try and remember where a quarter was, okay? So, here we go. Tracing paper on nice and straight. Draw over your triangle. Place your pencil on your point that you are rotating about. So 90 degrees anti-clockwise. So I'm going to go to the right, 90 degrees. So here we go. Quarter of a turn, and it's going to end there. So use your pencil and really push that in there. Okay, you can do it on the points if you want. There we go. So I'm just going to take that off. My pencil gone, yeah, I can feel that it's there, and it's across to there. So there we go, I'm just going to take that off. Draw that in. Just to make sure I've done it in the right spot. Just going to just double check that. And across, there we go, that's lovely. So it's always handy to check that. And there we go. So we've got a nice 2-mark question there where we've just rotated it. Okay. Part B. Enlarge triangle B by a scale factor of half using 0, 0 as the centre of enlargement. Now there's again a few different ways to do this question. So enlarge the triangle by scale factor of half. So even though it's asking me to enlarge, that scale factor is asking me to half everything. So I'm actually shrinking this triangle. Using 0, 0 as the centre of my enlargement. So there's the centre of my enlargement. Now I'm going to pick a vertex on this triangle, which is there. Okay, several different ways of doing this type of question. You can get your ruler and you can draw through all the vertices. But the way I do this question is that I then count from that vertex to that point. So it's 1, 2, 3, 4, 5, 6, 7, 8 diagonals across. So if I was to go from my centre of enlargement right the way down to that vertex on my triangle, it takes 8 diagonals straight the way through. My scale factor of a half not only means I'm shrinking my triangle, it means I'm also shrinking the distance between. So, scale factor of a half, 8 was my distance, 4 is half of 8. So, from my centre of enlargement, I'm going to count out 4. 1, 2, 3, 4. That point, that vertex of that triangle is now going to be there on my new shape. So I'm going to draw my triangle here. And instead of going up 2, 4, 6, half of 6 is 3. So I'm going to go up 3. That would be my next vertex. Instead of going across 4, I'm going to go across 2. So that would be my vertex there. Just draw that in. And there we go. If you did it in the way that you use the rays rather than the vertices, as you can see, if I was to draw those in, that's fine. You can see that they all match up. To go through that point. Okay, so like I said, several different ways of doing that question, and they're all, it doesn't matter which way you use, it's worth 2 marks. Okay, question number 11. We have our circle theorems question. Okay. P, Q and PR, so P, Q and PR, are tangents to a circle with centre O. RPQ, so RPQ, is 30 degrees. Find the size of angle OQR, so O up to Q down to R. That is the angle that's incorporated there. That's the one we're trying to find. You must indicate any angles you calculate. You must give a reason for each stage of your working. Now, looking at that, what I first know about tangents to a circle is that they're going to be the same distance from the point, both tangents. So the length of that tangent there is equal to that tangent there. So if I was to cover that part of the circle, you can see I've got a triangle here, and that triangle is an isosceles triangle, which means that the angles down here must be the same as each other. Angles in a triangle total 180 degrees. So if I do 180, take away the 30, that gives me 150. And if I split that equally between the two, that gives me 75 degrees. So each one of these here are 75 degrees. Okay. What I also know with my circle theorems is that a radius, or a radii, makes 90 degrees at a point where a tangent touches the circle. So if I was to look here, where that tangent touches there and this radius meets, that's going to form a 90-degree angle. So you need to make sure you are writing this down as you go along. So I should have written at the top there that tangents are equal in length. And then I've got that workings out to get that for my isosceles triangle. The next point I probably would have written is that a tangent and radius meet at a perpendicular angle, so at 90 degrees. Okay, so if that angle there is 90 degrees and that part there is 75, the angle I'm trying to find is going to be 90, take away the 75. So 90, subtracting that 75 gives me 15 degrees, and that is the angle there. Okay. Number 12. Using only a ruler and a pair of compasses, construct a perpendicular line from the point P to the line AB. So here comes our compass. So when you are putting in your pencil, make sure that you are doing it when it's closed so that those 2 points there meet. Okay, let's have a look at this. So if I want to do a perpendicular line, I need to chop this, and if I did a perpendicular bisector of this line, then I would chop this line in half, but it wouldn't necessarily go through P. So what I need to do for this one is extend, put the point on B and extend that out to P, and I need to mark an arc there, because what I'm looking for is to put a point on the other side of my line. So but I can make a straight line between them so that it cuts perpendicularly. I've just made up a word. And now we're going to do the same to the other side, but this time I'm going to do it from A to P and open that up and draw that arc through. So as you can see, they meet at this point here. So if I take my ruler and I join those two up, that now meets at 90 degrees. Again, that's a lovely 3-mark question there. Okay, good. Okay. Okay, 3 marks. There's 1 mark there for making sure that you draw the line in there. So that would be an easy mark to lose there if you didn't draw that line in. So make sure that that's in there. Okay. Okay, question number 13. Our standard form question. Express 0.00042 in standard form. So that means that standard form is always something times 10 to the power of something. Our first number has to be between 1 and 10, but can't include 10. So it's going to be 4.2, because those are the numbers I have here. But that means that my decimal point has moved. Not technically, but that's what I'm going to say. It's gone in 1, 2, 3, 4. So that 4 goes up there. But as this is a small number, not a large number, that is a negative 4 because it's a small number. So there we go, 1 mark for that. Okay, part B. Calculate the value of 7.2 times 10 to the power of 6 divided by 2 times 10 to the power of negative 2. Now this is where your rules on indices comes in really handy. So the first thing I'm going to take is this side, because it's multiplying, we can treat them separately. 7.2 divided by 2 is 3.6. Okay. And then I'm going to have times 10 to the power of something. Now, when I'm dividing indices, I subtract them. So I need to do 6 take away minus 2. So I'm going to have 6 take away minus 2. Got them touching, so it does become positive. So we are now going to do 6 add 2, which gives us 8. And that's the answer to that one. And part C, calculate the value of 4.7 times 10 to the power of 5. Take away 6.2 times 10 to the power of 4. Now, this isn't as easy or as simple as part B. This is worth 2 marks. So what you need to do, you need to take these out of standard form, do the calculation, and then put it back into standard form. So, let's do that. 4.7 times 10 to the power of 5 is going to give us 4, 1, 2, 3, 4, 5. It's going to give us 470,000. Take away 6. 1, 2, 3, 4. So as you can see, I was counting with the indice there. It's just a little trick there. So I'm actually going to do 470,000 take away 62,000. So 470,000 take away 62,000. Okay. Column method, or you can count up, it's up to you. So that's 0, 0, 0. We need to borrow here. So 10 take away 2 is 8, 6 take away 6 is 0, and then we've got the 4 there as well. That would be enough for 1 mark. The second mark, however, is give your answer in standard form. So So we need to now put this back into standard form. So my number at the beginning, again, remember, has to be between 1 and 10. So it's going to be 4.08 times 10 to the power of, let's count, 1, 2, 3, 4, 5. Okay, so big number, so it stays positive. And that's the answer to that one. Okay. 14. Lovely Venn diagram. A group of pupils from a school took part in the Urdd National Eisteddfod. All of them competed in at least one of the competitions, singing, dancing or reciting. 2 of them only took part in the dancing competition. 5 only took part in the reciting competition. No one took part in both the reciting and dancing competition. 3 took part in both the singing and dancing competition. 9 took part in a reciting competition, and 22 took part in a singing competition. The Venn diagram below shows some of the above information. The universal set contains all of the pupils in the group. One of the pupils in the group is chosen at random. What is the probability that this person only took part in a singing competition? Okay, to answer that question, what we need to do first is fill in this Venn diagram. So I'm going to go back up and I'm going to go through these again. So 2 of them only took part in a dancing competition, so that's already on there for us. 5 only took part in a reciting competition, so that's only reciting, so it's that part of my Venn diagram. No one took part in both the reciting and dancing, so I'm looking at reciting and dancing where they overlap. So reciting is here, dancing is there, and we've got 0 there because nobody took part in both. 3 took part in both a singing and dancing competition. So where singing and dancing overlap, singing and dancing, we are going to have 3. 9 took part in a reciting competition. So we've got to be careful now. 9 took part in a reciting. It's not saying that only took part in the reciting competition. It's 9 in total. So if we look at our circle for reciting, all those numbers must total 9. Well, we've got 5 that only did reciting, which leaves 4 that must have done the singing competition as well. And 22 took part in a singing competition, which means that our circle for singing must total 22. So I've got 7 there already, and I need another 15 to total that up to 22. Okay. The question is, however, what is the probability that this person only took part in the singing competition? Well, only singing is 15. But a probability has to be either in a decimal or fraction or percentage form. So it's 15 out of the total number of people. So if I add these up, 15 add 4, that gives me 19. Add 3 gives me 22. Add that 2 gives me 24. Add that 5, there's 29. So it's 15 out of 29 for our probability. Okay, so the key to that question is making sure you read that very carefully. Okay. Question 15. Factorize. Factorize x squared, take away 7x, take away 18, and hence solve x squared minus 7x minus 18 equals 0. Now when we factorize that, it's called a quadratic. When we factorize a quadratic, we put it back into brackets. And as there's no coefficient, well, as the coefficient in front of x squared is 1, we can pop it straight into the brackets by finding factors that make 18 that also add together to give 7. But we do have to be careful because it's minus 18 and it's minus 7. So on the side, I'm just going to write out the factors of 18. 1 and 18, 2 and 9, 3 and 6, not 4, 5 doesn't go into it, and then we're back to 6. Okay, so I'm looking for factors of minus 18, so one of these would have to be negative. That makes minus 7. So let's have a look at, is there a pair that I can make 7 from here? Yes, it would be that. I want to make minus 7, so that would be 2, take away 9, would give me the minus 7. And obviously then, 2 times minus 9 gives me the minus 18. So in my brackets, one of my brackets is going to be plus 2. The other bracket is going to be minus 9. And it does not matter which way round you put those. Next part of the question is, and hence solve that equals 0. So when something equals 0, it means that one of those must be 0. So either x plus 2 equals 0, or x minus 9 equals 0. So our solutions to this is that x could equal minus 2, or that x could equal 9. Okay, yeah. Okay, number 16. Solve the following simultaneous equations using an algebraic, not a graphical method. Now, these simultaneous equations, there are several different ways to do it. The method that I'm going to show you is a method that will work for any simultaneous equation. Whenever I do these, I always try to make the coefficient in front of my first variable, so in this case x, the same. And in order to do that, I take the opposite coefficient and multiply by it. So this top equation there, I'm going to multiply by 6, because that's the coefficient of the one below it. And the one at the bottom, I'm going to multiply by a coefficient of 4, because that is what's on the top one. So I'm going to rewrite those. Don't forget you have to multiply each of these terms by 6. So 4x times 6 is 24x. Take away 3 times 6, which is 18y, which equals 2 times 6, which is 12. And then I'm going to do the same to the bottom, but this time multiplying by 4. So 24x, take away 20y, which equals 4. Okay, so that's that first step. Now I'm going to label them 1 and 2. So equation number 1 and equation number 2. And I'm going to do 1 take away 2. So let's have a look at this. 24x take away 24x. Well, that disappears. That's the whole point of making those coefficients the same. Minus 18y take away minus 20y. So if I think about what I've just said minus 18y take away minus 20y. We've got two negatives here. They make a positive. So minus 18y add 20y. That gives me 2y, which equals 12 take away 4, which is 8. Now, 2 y's equal 8. One of those y's must equal 4. So now I have a solution for what y is. Y equals 4. And now I can take that 4 and put it back into any of my equations. So I can put it into 1, 2, or I could put it into my original ones to find out what y is. So I'm just going to use this top one up here. I'm just going to rewrite that. 4x minus 3y equals 2. I now know that y is 4, so I'm going to substitute that in. So 4x minus 3 bracket 4 equals 2. So let's just work that out a little bit. We've got 4x take away 3 multiplied by 4, which is 12, which equals 2. Something take away 12 is 2. That something must be 14. So x equals, we have to divide 14 by 4. So half of 14 is 7, half of 7 is 3.5. So my two solutions, y equals 4 and x equals 3.5 or 3.5, up to you. Okay?
That's why I messed up. I see.
You've seen it.
I see.
Okay?
The other one's right.
The other one was right. Good. There we go. Got one more question to go. Question number 17. Okay. A cylinder just fits inside a hollow cube with sides of length m centimetres. The radius of the cylinder is m divided by 2 centimetres. The height of the cylinder is m centimetres. The ratio of the volume of the cube to the volume of the cylinder is given by this following ratio. So the volume of the cube to the volume of the cylinder is k to pi, where k is a number. Find the value of k, and you must show all your workings. Now, this question looks quite complicated, but it's not that bad actually. It's talking about the volume of the cube and the cylinder. So let's work that out in terms of what we've got. Okay, so let's do the volume of the cube first. Now, to work out the volume of the cube, because it's a cube, it has the same cross-section throughout, we can just multiply the 3 dimensions. So we're going to have m multiplied by m multiplied by m. So we can simplify that down to m cubed. Okay, let's work out the volume of the cylinder. Now, if you had at the beginning written down all your formulas, you wouldn't have to do much thinking about this one, because on our formula sheet here, our volume of our cylinder is pi r squared h. So I'm now going to substitute in my values from the question. So pi remains as pi, multiplied by my radius squared. So my radius is m over 2 squared, multiplied by my height, which is m. Okay, we need to tidy that bit up a bit. So we're going to do pi times, okay, m over 2 multiplied by m over 2. Let's have a look at that. M over 2 multiplied by m over 2. When we multiply fractions, we just multiply across. We're going to have m squared over 4. There we go. M squared over 4 multiplied by m. So I can simplify that down a bit more actually, because we're multiplying by m. So we're going to have pi multiplied by m cubed over 4. Use this bit of paper here. Okay, that's the volume of my cylinder. So let's put it into this ratio now. The volume of the cube was m cubed to the ratio of pi times m cubed over 4. If I look back to my ratio over here, it's k to pi. So on this side of my ratio, I only want pi. I need to move all of that. So if I want to remove the divide by 4, I have to multiply the other side by 4. So I'm going to get 4m cubed to the ratio of pi multiplied by m cubed. So instead of multiplying this side of my ratio by m cubed, I'm going to divide this side of my ratio by m. 4m cubed divided by m cubed to the ratio of pi. And when I get down to there, I can see that these m cubes would just cancel. And on that side, I am left with 4 to the ratio of pi. And if we look over here, it tells me k is a number to the ratio of pi. So k equals 4. And that's the end of that paper.